Using vertex formulas. For the standard form of the quadratic, f of x is ax squared plus bx plus c. The vertex is found by substituting x equals minus b over 2a and then plugging that value of x into f to find y. If you have the vertex form, f of x equals a times the perfect square x minus h squared plus k, the vertex is just hk. If a is positive, it's greater than 0, the vertex is the lowest point because the parabola opens up and we have a minimum value at the y value of the vertex. If a is less than 0, the parabola opens down, the vertex is the highest point with the maximum value at the y value of the vertex. Let's consider an example. We're given the standard equation of a quadratic f of x equals 3x squared minus 12x plus 16. We want to figure out whether it opens up or down, determine the vertex, and determine the maximum or the minimum. And I know that a is equal to 3. Therefore, because the leading coefficient is positive, I know the parabola opens up. b is equal to negative 12, and of course c is 16. So to find the vertex, I have to solve for x equals minus b all over 2 times a. So that means x equals minus 12. So I'm going to get positive 12 divided by 6. X equals 2 is the x value of the vertex. To find the y value of the vertex, I have to plug 2 into my function. So y is equal to f evaluated at 2, and that's going to give me the number 4. So this vertex is at the point 2, 4, and because the parabola opens up, this will give a minimum value. The minimum always occurs at the y value of the vertex, so the minimum value of this function is y equals 4. So we can see from the graph it does indeed open up, and the vertex is here at the point 2, 4, and of course the minimum, the smallest possible value which the function does achieve, occurs at y equals 4. We often use quadratic functions to model projectile motion. If we have a 6-foot tall basketball player, he's shooting a free throw standing 15 feet away from the rim, and he holds the ball above his head at 7 feet and throws it at 25 feet per second at an angle of 45 degrees. We can model this situation by using the equation for height, h of t equals minus 16t squared plus 25t plus 7. T here is time in seconds. How high does he throw the ball? We have to find the vertex. So I'm seeking the vertex. What is the highest point that he throws the ball? And that is here at the vertex. And I'll use my formula. So that is when t, instead of x now I have t, is minus b all over 2a. And for my equation in h of t, I know that a is equal to negative 16 and b is equal to positive 25. So the t component of the vertex is 25 divided by 32, and that means t is going to be 0.78125. And I'm not using approximation symbols here, I'm using equals because this decimal is exactly 25 30-seconds. So h at 0.78125 is approximately 16.8 feet. The vertex then is 0.78, I'm going to approximate that, seconds, and it reaches 16.8 feet in height. So how high does he throw the ball? He throws it 16.8 feet high.